Hey, good morning, good afternoon, good evening. Welcome back to another Coding Not So Everyday Until I Get a Job. This is a 141 insertion short, continuing
In
the
this video, let's
um,
take a look at the second sorting algorithm,
what do you
which
call it?
is insertion.
Continuing the
Let's move on.
playlist for the JavaScript
The
DSA.
problem statement remains the same.
Okay, I
An
forgot
array of
the
integers
insert.
sort the
What
array.
is the
Sorting can either be ascending or
insertion
descending.
sort is?
For example, if we have an array of 5 integers, passing the array into insertion sort function should return the same array in ascending order. Let's first understand the idea behind insertion sort. With insertion sort, you virtually split the array into a sorted and an unsorted part.
Is it
Since the
the
order,
wait? Yeah, I
by
forgot.
definition, is always sorted, we assume that the first element is sorted and remaining elements are unsorted. You then select an unsorted element and compare with all the elements in the sorted part. If the elements in the sorted part is smaller than the selected element, proceed to the next element in the unsorted part. Else, shift larger elements in the sorted part towards the right.
I forgot which one is it. Wait, yeah,
Then,
let's try to.
insert the selected element at the right index, ensuring the sorted part remains that way. Finally, repeat the above steps for all the unsorted elements in the array. Of course, these points might be difficult to understand, so let me help you visualize with an example. Consider the array from our example.
Okay.
6, 20, 8, minus 2, and 4. I've omitted the comma as it gets a bit too crowded. Here is how insertion sort works. You begin by assuming the first element in the array is already sorted. Remaining 4 elements are unsorted. You start at index 1, which is the first unsorted element. Let's store it in a variable called number to insert, or NTI for short. You compare it with the sorted elements on its left to see if it is out of order. We have one sorted element, which is minus 6. Let's represent that as SE, sorted element for short. We check if the sorted element is greater than the number to insert. Is minus 6 greater than 20? The answer is no. In that case, place 20 to the right of minus 6. Of course, there is no change in our scenario as 20 is already to the right of minus 6. Minus 6 and 20 now form the sorted part of the array. Next, we pick 8, which is from the unsorted part of the array. Let's store 8 as number to insert. We compare it with the sorted elements. First, we start at 20. Is 20 greater than 8? Yes, it is. So shift 20 one position to the right. We now have 20 twice.
Would it
That is okay.
use the
20 is stored in a
temp
variable called
variable
number
again?
to insert, and we haven't lost track of it. After 20, the next sorted element is minus 6. Is minus 6 greater than 8?
Okay, but it does
So
two
place
comparison.
8, which is the number to insert, one position to the right of minus 6. Our sorted part of the array is now minus 6, 8, and 20. The next unsorted element is minus 2. Compare it with
I
the
think this
sorted
would
part
need
and shift the
the
sorted elements as
recursion,
necessary.
no? Or
Is 20 greater than
I
minus
don't
2?
know. We'll see how it
Yes,
goes.
so shift to the right.
Or how is it
Next, is
implemented?
8 greater than minus 2? Yes, so shift to the right. Next,
Because,
is
okay.
minus 6 greater than minus 2?
The NTI, it's gonna
No,
be
so
another
place
like
minus
pointer,
2
right?
to the
But
right of minus 6.
that one's gonna just
So the
change,
sorted
okay.
part is now minus 6, minus 2, 8, and 20. Finally, the unsorted element is 4. Compare again with the sorted part which lies to the left. is 20 greater than 4?
Hello,
Yes,
welcome.
so shift 20 to the
I
right.
am doing,
Next is
I
8
guess I'm just a
greater
bit
than
tired
4.
and exhausted, I guess,
Yes, so shift to the right.
and need to sleep properly
Next
tonight,
is
but
minus 2
I'll try to
greater than
do
4. No, it is 4 to the right of
for
minus
my
2.
part-time, or is it just doing the
Our sorted
coding
array
stuff
is now minus
and
6,
projects and
minus
everything?
2, 4, 8, and 20. We have reached the end of the array, which means the entire array is now sorted. This is how the insertion sort algorithm works. Alright, if you've understood the algorithm, now is the time to pause and implement the solution. If you would like to solve together, let's do so in the next video.
Yeah, please, solve together.
In this video, let's take a look at the solution for insertion sort.
How do we do it?
In Replit, let's begin by defining the function signature. Function insertion sort, parentheses and curly braces. The function will have one parameter, arr, which represents the array to sort. For example, if we have an array 8, 20, minus 2, 4, minus 6, and we pass the array into the insertion sort function and then log the array to the console, we should see the elements sorted in ascending order. Now, what do we know about insertion sort? We know that the first element is assumed to be sorted, and we need to traverse the unsorted part of the array. The unsorted part starts from index 1 till index array length minus 1. To achieve that, we can use a for loop. For let I is equal to 1, I less than array dot length.
Coding, I guess in general, daily, if I'm not streaming, I mean, I'm doing another project as well. I do probably like 2 hours. The streaming is usually, although not every day, so it's like another 1 to 2 hours. So probably daily around 4 to 5 hours.
Is equal to array of I. Next,
Are you planning to buy a MacBook? Well, if I get a job, probably might upgrade some laptop, but to be honest, I'm more interested in daily driving Linux, to be honest, although since I want to make more videos as well, and I think Mac is also good for that, so it is also compelling, but as of right now, I guess the goal was just to maximize the gear and things that I have right now, but it's hopefully if we able to land a role.
Element in the sorted part. And we know that the sorted part always lies to the left of the unsorted part. For example, minus 6 is at an index that is 1 less than the index of the number to insert. So, let j is equal to I minus 1. Here, j refers to the index of the sorted element. Now, the sorted elements can be more than 1. We need logic to iterate over the sorted part of the array. For that, we are going to use a while loop.
Okay, this is...
While j is greater than or
yeah, I mean, like, I kind of want to try Linux, daily driving Linux compared to that, but also if I want to make more videos and content creation stuff, Mac is definitely better.
We decrement j in each iteration. But we also need to check if the sorted element is greater than the number to insert. Otherwise, there is no need to iterate further to the left. Let's add a condition for that. And array of j is greater than number to insert. If this is the case, for example, 20 is greater than 8, we need to shift the sorted element to the right by 1 index.
Yeah, the thing is, even if I chose to change to Mac, it's definitely gonna be a MacBook laptop rather than a desktop, you know, like since it's very good, has a good battery, good everything, like using it as like a main
right
daily
A,
driver powerhouse, I think I prefer it
once that
if
is
it's
done,
like a MacBook
J
Pro
will point
laptop
at the index where the
or
condition
MacBook
has to
Air,
happen,
you know,
or the sorted element
because
is
the
lesser
Mac
than the number
Mini
to
is,
insert.
you know, you still need a monitor. I mean, I have
With
it, but I kind of want to be more mobile if I
minus
have
6
like a
is less
MacBook,
than
right?
8, we insert 8 to the right of minus 6. So array of j plus 1 is equal to number to insert.
Yeah, okay, this
That
insertion
is
short
our
thing
implementation
is
of insertion short.
confusing.
Let me summarize the code. We use a for loop to iterate on
Yeah,
the unsorted part of the array. We store the number to insert in each iteration. We compare the sorted elements in the array with the number to insert, trying to find the index where the insertion has to happen. The index is where sorted element is lesser than the number to insert. You then insert the number to the right of that index. Now, if this was hard to follow, let me tell you, it is hard to follow.
it is hard to
Don't
follow,
stress
yes.
yourself if you didn't get this in the first go. Please rewatch the video and it will slowly start to make more sense. Alright, let's verify by running the code.
Yeah, let me try. Okay. So we have an unsorted array. We need to loop it over, the assumption is that the first element, which is the 0th index, is actually already sorted. So we're gonna check the length of that array, increment it, of course, and then we have number to insert. Number to insert is the first element. Okay, we have j, which is I minus 1. So I is the first index, and j, in this case, the first loop at least, is going to be 0. That means, okay, while j is greater than equals to 0, and if the array of j, which is that, in this case, the number 8 in our array, is bigger than the number to insert, j plus 1 equals to array j. Okay. This is confusing. Okay, yeah, let me try it. Let us try to like do it step by step on every iteration. Yeah, let's see. Yeah, let's say we have the 8, 20, negative 2, 4, and negative 6. This is the 0, 1, 2, 3, 4. We start with the for loop at the I. So here, number to insert, it's going to be equals to 20. Number to insert is 20. And we have j equals to 8, or basically j is equals to 1 minus 1 is 0. So j is going to be 1 minus 1, which is equals to 0. And it is actually the true on the while loop. And the next one is array j. In the first, it's going to be array of 0, which is the number 8. And if 8 is greater than number to insert 20, which is false, that means this loop isn't going to work, because the condition is if it's j, because it's only 1, and this is the and logic conditional, so it's going to get out from here, and it's going to be array j plus 1. Array j plus 1 in this case is 0. Plus 1 is going to be array to 1. And now array position number 1 is the number to insert. Mac Mini is much more expensive here. Yeah, everything Apple here is a bit more expensive, I believe. How can we change that? Okay, that is complete bonkers. Okay, let's just duplicate them and let's run them.
We see the sorted array. Our code works as expected.
Okay, how?
What I would like you to do is take a pen and paper and trace the function execution for a different array. Once for a sorted array.
Oh yeah, because it's already sorted. That's why it doesn't change, because the left and right is already sorted. Now it's going into, now I is number 2. Yeah, this is like the first loop, and then in the second it's going to be 2. The I is going to be 2, and J is going to be 1 now. J is equals to be 1, and since J is over than 1, yes, and it's correct, and number to insert is the 2, and in this case number to insert is the -2. Since the array J is now 20 and our number to insert is -2, and the comparison is true because 20 is higher than -2, then the array J value, okay, array J in this case is 1, so array number 2 is going to be array J. Oh yeah, basically it swaps the 2 equals 2. I saw a refurbished post on eBay, $0.06 per gigabyte. Oh wow, really? That is actually not a bad deal, no? 64 GB, 2 terabyte, and the one M1 Max. I watched a video recently regarding the M1 Max, and people said that it's still very, very good. So, yeah. But it's from the US, right? Like it's, I don't know. Maybe it's not available here in EU, but who knows?
And once for a reverse sorted array where the elements are in descending order. That will really help you understand the insertion sort algorithm. Alright, next it's time to determine the big O of our insertion sort function. Pause for a minute and determine the big O.
Would it be an n squared again because it's nested?
Now, let's estimate the big O together. Our function contains 2 loops, a while loop nested inside a for loop. From our cheat sheet, it is pretty evident that big O is quadratic time complexity. Big O is equal to O of n squared.
N squared, yeah, quadratic.
As the number of elements in the array increases, the number of comparisons increases by square of that number. So that is about insertion sort. In the next video, let's take a look at quicksort, which uses recursion.
Okay.
Thank you for watching. Please do make sure to subscribe to the channel, and I'll see you. Welcome back, everyone. In this video, let's take a look at the third sorting algorithm, which is quicksort. The problem statement remains the same.
But how is it different? Is it the same but it's using
sorting
recursion?
ascending or descending. For example, if we have an array of 5 integers, -6, 20, 8, -2, and 4, passing the array into a quicksort function should return the same array in ascending order. Let's first understand the idea behind quicksort. You begin by identifying the pivot element in the array. Now, how do you decide what is the pivot element? Well, you have plenty of options to choose from. You can either pick the first element in the array, the last element in the array, a random element in the array, or the median. For our solution, we will be picking the last element in the array as the pivot element. Now, what role does the pivot play? Well, you traverse the array from the first element to the last but one element and you put everything that's smaller than the pivot element into a left array and everything that's greater than the pivot element into a right array. You repeat the process for the individual left and right arrays till you have an array of length 1. An array of length 1 is sorted by definition. When you reach that base condition, you simply concatenate the left array, pivot, and right array in that same order. You continue till you're left with one.
Wait, 1 second.
Array, which would be the sorted array.
Oops,
Let me
something.
help you visualize with an example. Consider the same array. -6, 20, 8, -2, and 4. First, identify the pivot, which is the last element in the array. Now, the remaining elements are split into a left array and a right array. The left array contains elements less than the pivot, so -6 and -2. The right array contains elements greater than the pivot, so 8 and 20.
How do you decide
Next,
that?
you repeat the same party 2 and 4. First, identify the pivot, which is the last element in the array. Now, the remaining elements are split into a left array and a right array. The left array contains elements less than the pivot, so -6 and -2.
I saw, okay. Left element less than pivot. Ah, okay, I
The right
see.
array contains elements greater than the pivot, so 8 and 20. Next, you repeat the same partition for the left and right sub-arrays. For the left array, pivot is the last element, which is -2. The left array will contain smaller elements, which
Yeah,
is
okay.
-6.
It's quite similar
Right
to the
array will
graph
be empty as smaller
in
elements
the
are larger
lecture
than the pivot.
from CS50.
Similarly, on the right sub-array, the pivot is the last element 20. The left array will now contain 8 as it is smaller than 20, and the right array will be empty. Now, if the arrays contain only one element, we have reached the base condition. You now start concatenating the arrays at each level. -6, -2, and empty array will produce -6, -2. Similarly, 8 and 20 and empty array will produce 8, 20. We then move one level up where 4 is the pivot element. You once again merge left array, pivot, and right array. This will give the final sorted array.
Wow.
This is pretty much how the quicksort algorithm works. Alright, if you've understood the algorithm, now is the time to pause and try implement the solution. If you would like to solve together, let's do so in the next video.
Yeah, you know what? I'm not
In this video,
aiming
let's take a
to
look at the solution
solve it right
for
away.
quicksort.
I'm just learning it first.
Let's begin by defining the function signature.
This is hard.
Function quicksort, parentheses, and curly braces. The function will have one parameter, arr, which represents the array to sort. For example, if we have an array and we pass that array into the quicksort function and log the return value to the console, we should see the elements sorted in ascending order. Now, our first step is to find the pivot element. We know it is the last element in the array.
Okay, we're gonna create a let pivot.
Is equal to array of array.length minus 1. Step 2, we traverse the array and put the elements into a left and right array. Let's create two arrays. Let left is equal to an empty array, and right is equal to an empty array. Next, add a for loop to traverse the array. For let I is equal to 0, I less than array.length minus 1, I++. With each element in the array, we compare with pivot and then push into the appropriate array. So if array of I is less than the pivot element, push to the left array. Else, push to the right array. Repeat this for the left and right sub-arrays and eventually concatenate it with the pivot element. So return an array where we call quicksort on the left array, quicksort quicksort on the right array with pivot element in between the two. What we have here is recursion, so we need a base case to exit. And the base case is if the array contains one element. So at the top, if array.length is less than 2, return array. This is the quicksort algorithm in JavaScript.
So sorry, why did it the best case is if the length is less than 2?
Let's verify by running the code.
How?
What we have here is recursion, so we need a base case to exit.
And why does it use the
Base case
spread
is
operator
array contains
again?
one element. So at the top, if array.length is less than 2, return array. This is the quicksort algorithm in JavaScript. Let's verify by running the code. We see the sorted array. Our code works as expected. What I would like you to do is take a pen and paper and trace the function execution for a different array. Once for a sorted array and once for a reverse sorted array where the elements are in descending order. That will really help you understand the quicksort algorithm. Alright, next it's time to determine the big O time complexity of our quicksort function.
Would this be log of
When it
n?
comes to quicksort,
Because
I like to highlight both the worst case complexity and the average case complexity.
okay.
The worst case complexity is O of n square.
Oh,
This
really?
happens when the array is already sorted. Instead of partitioning our array into smaller arrays, we end up partitioning into an empty array and a full array. You end up comparing with every other element, and that would be quadratic time complexity. However, quicksort algorithm is a popular algorithm because its average case complexity is O of n log n.
Oh, n log
also
n, not
divide
just
the
log
array
n.
into smaller arrays, which is log n. And we also have a for loop, which is O of n. Combine the two, and we have O of n log n. Of course, the way to derive this complexity is complex and is out of scope for this fundamentals series.
Okay.
Now, it is very unlikely that you would sort an already sorted array. So the worst case complexity, even though is quadratic, the average case complexity is what matters with this algorithm. On a side note, it is also possible to implement the same algorithm without taking extra space. I'll leave a link to the code in the description down below for you to understand when you have the time. It is pretty helpful when you have space constraints. If you don't have any space constraints, you can go with the solution we have implemented now, or you can go with the merge sort algorithm. How does merge sort work? Well, let's take a look at that in the next video.
Cartesian product? Oh my god.
Welcome back, everyone.
Wait. Let me try to figure this out. Yeah. What is it? A quick sort. If array length is 2, then it's not. Let's try red fonts air 2. This is gonna be 3 and 0.
In this video, let's take a look at our in this array.
pivot equals to the last element of the array. Left is an empty array, right is also an empty array. We loop through the array and check if the number of the first is less than the pivot. Yes, it is. That means it's going to put left. Sorry, it's going to put -6 into the inside of the left array. And it's just going to return this again. And it's, okay, this is confusing. How does it run? Maximum call stack exceeded? No. Okay, maybe we can just do one. Is it because of that? How come it maximum? Oh, okay. Is it okay? Why is it not?
Quicksort on the array contains one element.
Did I forget to put? No.
So at the top, if array dot length is less than 2, return array. This is the quicksort algorithm in JavaScript. Let's verify by running the code. We see the sorted array.
Mine doesn't work. Okay. Huh, okay. That's odd. Maximum call stack size exceeded. Why? Did I forgot to write the best case or? Okay. I don't know why does that work. Is it due to the memory constraint? Is it using too much? Huh, okay. Merge sort it is, I guess.
Welcome back, everyone. In this video, let's take a look at our last sorting algorithm, which is merge sort. The problem statement remains the same. Given an array of integers, sort the array. Sorting can either be ascending or descending. For example, if you have an array of 5 integers, -6, 20, 8, -2, and 4, passing the array into merge sort function should return the same array in ascending order. Let's now understand the idea behind merge sort. First, you divide the array into sub-arrays, each containing only one element. An array with one element is considered sorted. For step 2, you repeatedly merge the sub-arrays to produce new sorted sub-arrays until there is only one sub-array remaining, which will be the sorted array. Let me help you visualize with an example. Consider the same array, -6, 20, 8, -2, and 4. As I mentioned in the previous slide, merge sort is a two-part process. First, you divide the array until you're left with sub-arrays that contain only one element. And the logic for that is to split the array at the middle till you have an array of length 1. So the array would now be two arrays, -6 and 20 in the first, 8, -2, and 4 in the second. Now check if the array length is 1. It is not, so we further divide the arrays. This time, -6 and 20 as two separate arrays, and for the right hand side, 8 is one array, -2 and 4 is another array. Remember, we split in the middle.
So it's gonna do using the math floor again, divided by 2.
One element and divide those. So the rightmost array will now split into -2 and 4. At this point in time, we have every element in the original array contained in its own sub-array. Step 1 is complete. For step 2, we merge the individual sub-arrays into new sub-arrays while ensuring the elements are sorted. Here is how it works.
How?
We take the two arrays and a temporary empty array to hold the elements as they are sorted. Let's start with -6 and 20. -6 is the left array and 20 is the right array. We check that the arrays are not empty. We then compare the first element in each array and push the smaller element into the temp array. Here, -6 is less than 20, so we remove it from the left array and push it into the temp array. Next, we see that the left array is empty. So we simply push the element in the right array onto the temp array. When both the left and right arrays are empty, we have the sorted sub-array. That would be -6 and 20. Let's repeat this process for 8 and -2, 4 to make sure we get this right. We have the left and right arrays. They are not empty, so we compare the first element in each array. -2 is less than 8. push it onto the temp array. Left and right arrays are still not empty. So we compare the first element in each array one more time. 4 is less than 8. So push 4 onto the temp array. Now the right array is empty. We simply push the left array onto the temp array. Both arrays are empty, and we now have the sorted sub-array. Let's repeat this process one more time for -6, 20 and -2, 4, 8. We have the left and right sub-arrays. Both are not empty. We compare the first element in each array. -6 is less than -2. Push -6 onto the temp array. Left and right are still not empty. Compare the first element in each array. -2 is less than 6, so push -2 onto the temp array. The arrays are still not empty. Compare once again. 4 is less than 20, so push 4 onto the temp array. We still have an element each, so let's compare one last time. 8 is less than 20, so push 8 onto the temp array. Now the right array is empty, so push the left array element onto the temp array. Both arrays are empty, and we have just one sub-array left, which is the sorted array. -6, -2, 4, 8, and 20. This is how merge sort algorithm works. Alright, if you've understood the algorithm, now is the time to pause and try implement the solution. If you would like to solve together, let's do so in the next video. In this video, let's take a look at the solution for merge sort. Let's start with the first part, which is only concerned with dividing the array till the sub-array length is 1. Back here in Replit, in index.js, let's begin by defining the function signature. Function merge sort, parentheses, curly braces, and the function will have one parameter, arr, which represents the array to sort. For example, if we have an array, and we pass that array into the merge sort function, and then log the array to the console, we should see the elements sorted in ascending order. Now we know we need to divide the array till its length is 1.
While array.length.
Base case for recursion.
Or if
array.length is less than 2, return array. Next, let's go back to dividing the array. We divide right at the middle. Let's calculate that first. Const mid is equal to math.floor array.length divided by 2. Now, we consider all elements from the first element up to, but not including the middle element as the left array. So const left array is equal to array.slice 0, mid. The rest of the array would be the right array. Const right array is equal to array.slice mid. And this would be till the end of the array. The left and the right arrays may still contain more than one element. So we have to repeat these steps for both the arrays. So we call merge sort left array, merge sort right array. Bear with me while I complete this line. Return merge, passing in merge sort of left array and merge sort of right array. So what we are doing here is dividing the array till they contain only one element.
And then we need to make the merge function
into a merge function.
Okay.
Which will be part 2 of the algorithm. In the previous video, we have understood in detail how the merge works, so let's write the code. Function merge, and this will receive the left and right arrays as parameters. Within the function body, we create a temporary array to hold the sorted elements. Let's call it sorted array. Next, we check that both arrays are not empty. So while left array dot length is positive and right array dot length is positive, as long as this condition is true, we compare the first element in the two arrays and push the smaller element onto the sorted array. Left array of 0 is less than or equal to right array of 0. We push onto the sorted array the left array element. We use shift since the element should also be removed from the left array. However, if the right array element is smaller, so else sorted array dot push right array.
I forgot what does the shift do.
Keep in mind the shift method removes the element from the corresponding array.
Okay.
Now, if one of the arrays is empty, we exit the loop. We then merge the sorted array with whatever array still contains the elements. We will use the spread operator for that purpose. So with the sorted array, so spread sorted array, if the left array still has elements, merge them. If the right array still has elements, merge them. The order is important to ensure the resulting array is sorted. Finally, return the resulting array, which would be sorted. This is the merge sort algorithm in JavaScript. Let's verify by running the code. We see the sorted array. Our code works as expected. What I would like you to do is take a pen and paper and trace the function execution for a different.
I forgot, what does the slice method in JS do? It takes only from the input and output, right? Fruit slice 1, 2, 3, it's just gonna take the orange until the apple. Ah, okay. So it takes the chosen one until number 3, so 0, 1, 2, 3, orange and lemon. So the 3 is not included in the index. Okay. Negative value, -3. So it's gonna be -1, -2, -3. It's gonna be just lemon and apple, I would assume. Yes, okay. Okay, let's try to trace this, yeah? Okay, let's try to run it. Okay, why does it use its maximum call stack? Is it something that I wrote wrong? Does it not have enough memory? Something I don't get with the okay. Run JS direct run JavaScript online. I don't know. Let's just I just want to run this. Yeah. What is it? This is actually pretty cool. Wait, let me check. Is it something? Is there something like simpler? Just this is a bit too much. Yeah, just run JS, write a code, and yeah. Okay, how come the replit allows it and everybody just the other just ran out of memory? What did I do wrong? Why am I running out of? Okay, I'm gonna ask ChatGPT or Grok. Why does this? Why? Hello, Mr. Bestress. Yes, and after this, I'm going. So here's the plan, at least for like the next 2 weeks. I'm gonna finish the DSA and just basically drown myself in JavaScript until I get sick and tired of it, even though I don't feel like my knowledge is increasing. But then after that, I want to start making project again, something with UI, which what makes it me interested in doing this at the first place. So the next part is CSS. After this, I'm going back. Yeah, I know. Ah, shit. Okay, sorry. Sorry, I. God damn it. Okay, that is such. I'm so stupid, man. Oh, I didn't. I forgot to put. Oh God. Okay, thank you. That works. Yeah, yeah, yeah. That is. Oh my God, I forgot to put the parameter. Yeah. Okay. Sorry. Okay. Let's trace this one by one. Yeah. Let's use like a tail draw or something so that we can have some thing to write down. Okay, can we grade? Oops. Okay. What is this? Three various. Okay. So first, since we already have -6, we have -6. Okay, this is not helping. Wait, let me type it. So we have -6, 20. Okay, no, this is actually much better if I just. Okay, now let's do this. -6, 20, 8, -2, and 4. This is the 0th position. 1, 2, 3, and 4. So let's run it one by one. If array.length is less than 2, this is not, because we have 1, 2, 3, 4, 5. So we're going to skip it, and we're going to create mid. Mid is going to be the length, which is 5, divided, okay, wait. It's going to be 5 divided by 2. It's going to be 2.5, but since we're using the floor function, it's going to be 2, which means mid is going to be 2. We have left array, which is goes from 0 until mid, which is 2. So since using the slice, it's only, so left, it's going to take the -6 and 20 only, because using slice. And for the right array, it's basically from the number 2, which is 2, until the end. So it's going to take, so right is 8 minus 2 and 4. Right? Yes, you should go for masters. Ooh. Okay, let's see. Is it, the thing is, do I need to pay? That's the thing. Free? Oh my god, okay. This one, the last algorithm, this is one, right? Yeah, okay. Oh, 9 hours. Okay, this is actually, but do I need to pay if I want? Okay, yeah, no, it's fine. Yeah. Okay, okay. How can I join? Get free access? I need to sign up. Okay, okay. Wait, no, if I'm not mistaken, okay. No credit card, no cash, credit free account. 5 full for, oh, okay. So if I created a free account, let's check the preview. It's probably gonna be him joking about these nuts, and never mind.
Hi, my name's the Primogen. I'm an engineer at Netflix, husband to a beautiful wife, and a father of 4. I love data.
He has 4 children? Holy shit. Okay.
Not only are they useful in your daily job, they make you a better engineer. In this course, we're going to cover arrays, lists, trees, graphs, maps, and some interview questions I've had along the way that use one or more of those. Along with that, we're going to cover some algorithms, including searching and sorting. Remember, this is engineering. The best thing to do is have fun, so I hope you enjoy this course. We're going to first tackle Big O, because I do feel like Big O is kind of that one thing that if you don't know it, it just means I'm going to be saying a bunch of nonsense
Okay.
here, and it just kind of sucks, because then we keep talking about it and you don't know what it is. So Big O, the easiest way to put it is that it categorizes your algorithm on time or memory based on the input. It's not meant to be an exact measurement, so if someone's not going to say, oh, your algorithm's going to take 450 CPU units. You're going to first say, well, what's a CPU unit? And second, how did you come up with that exact number? Instead, it's a generalized way for you to be able to understand how your algorithm will react as your input or the things you are using grow. And so if someone says, oh, this is O of n, what they mean is your algorithm is it grows linearly based on input. We'll go over some more.
Okay, this is actually pretty nice. Okay, I'll note it down. If I probably gonna do it on my own free time, not streaming it, because I have a plan already, hopefully. Okay. Watch normal speed because it's very fast. Okay. Okay, still in progress, so I'm gonna finish this first, but I'm gonna note it down because this is actually pretty nice.
Array. Perhaps once for a sorted array and once for a reverse sorted array where the elements are in descending order. That will
Yeah,
help you understand
okay,
merge sort
roger that.
algorithm.
That is actually really good.
Alright, next it's time to determine the big O of our merge sort function.
Sorry, yeah, we're going back here. Okay, it's already split that. And then it's gonna return the merge function, which we already have left array and right array. Oh, it's recalling the merge sort again. And okay, we have the left array, which is 6 and 20. It's basically just gonna split it in half again until uh they are just -6 and 20. And by then, this merge sort, it's gonna return the -6 and the -20. Oh, okay. Yeah. This is like a... Okay, I don't understand how to visualize it, but... Oh man, okay. Visualized. Let's see if this works. What? What is this? Wait. Oh, I like the styling. It's very nice. The color. But whoa, it looks cool. Okay, so it runs the merge sort, separated it, merge sort again, right? Until they are split into left and right. And okay, I don't Yes, please, if you have. This is confusing. I get that this it's basically gonna call this merge sort again function that's just splitting the array into tiny arrays, and then if that's done, it's gonna call the merge, and after the merge, it's gonna do the switchy, and then blah, and then like the push mix, and then like return that already sorted array. Oh, please, if you have any better way of explaining it.
Now there are two parts to this. We recursively divide the problem into halves. And this, if you remember, is log n time complexity. Second part, we merge the arrays, and this contains a while loop. If there is a loop, the time complexity is linear.
Oh my god, okay.
The solution is
Oh, so we made Discord. You can share it there if you want. The link in the description. Hopefully it's the correct one.
The resulting time complexity
if you
is
want.
O of n log n. So big O is equal to O of n log n. And this is one of the best time complexities you can get when sorting. Alright, that is about merge sort.
Okay, wait, let me try to copy it. What the fuck? Never mind. No, the video is not available anymore. Why? I typed the correct code, right? No? Okay, never mind then.
Please do make sure to subscribe to the channel, and I'll see you in the next one. Welcome back, everyone.
Ah, so okay. This one? Or this one? Or this one? Or this one?
The event loop is a pretty notorious topic in JavaScript, but when we zoom out, it's just a tiny component within the JavaScript runtime. We also have the call stack, we have web APIs, we have the task queue, micro task queue, and then eventually the event loop. Well, to be a little more technically accurate here, we actually have the JavaScript engine, in which we have the call stack, and then also the memory heap, but to keep my slides a little organized, I'll just be showing the code
Okay.
here. All these components together allow us to use asynchronous tasks in a non-blocking way in JavaScript. And this is important because JavaScript itself is single-threaded. We're only working with a single call stack. So the call stack manages the execution of our program. So if we have the following script, we first have console log 1. So a new execution context is created, pushed onto the call stack, which is then evaluated and logs 1. Then we have console log 2, same story. Execution context is created, pushed onto the call stack, is evaluated and logs 2. Then on line 14, we invoke another function, the log 3 and 4. And within this function body, we invoke yet another function, log 3. And within log 3, we invoke another function, the console log 3. Eventually it logs 3. Then on the second line within the log 3 and 4 function body, we console log 4. 4 gets logged, and now the log 3 and 4 execution context is popped off the call stack as well. Now something important to remember here again is that JavaScript can handle a single task at a time. So if we, for example, had this long running task in which we have a pretty heavy computation, it takes a while before JavaScript can continue with the rest of our program. So the console log long task done is only logged after a couple seconds. And this is not what we want, because in the meantime, our entire program is frozen. So we want to avoid these long running tasks. But in a real life application, we often have to use these long running tasks, like maybe a network request or anything based on user input, timers. So what happens
And this leads
is our entire call
to
stack
like
is blocked until we get the data back.
promises,
Now,
async
actually
await,
using web
right?
APIs in those cases. And web
This
APIs
event loop
provide
is
a
what
set of
allowed like the
interfaces that
async
allow us to interact with the browser solution.
asynchronous
This includes functionality
promises,
that we often use, like the document
the
object
callback.
model, fetch, set timeouts, and so many more. The browser is a very powerful platform with a lot of features. Some of these features are required, like the rendering engine or the networking stack, but we also have access to some cooler ones, like device ones, sensors, cameras, geolocation, and so on. Okay, cool, but what does this have to do with long-running tasks? Well, some of these web APIs allow us to offload long-running tasks to the browser. So when we invoke such an API, we're kind of just initiating that offloading. And web APIs that expose these asynchronous capabilities are either callback-based or promise-based. So first, let's focus on the callback-based APIs, and I'm just going to use the geolocation API because it's fun. I could have used any other callback-based API, but let's say that we want to get the user's location. And for this, we can use the getCurrentPosition method exposed by the geolocation API. And this receives two callbacks. First, we have the success callback, in case everything goes well and the user allows us to get the location and we actually get it from the browser, or the error callback in case anything goes wrong. So let's see what happens when we actually use this in our script. So first, the getCurrentPosition invocation gets added to the call stack. However, this is just to register those callbacks and initiate that async task. After doing that, it can get popped off the call stack immediately, so it doesn't wait for any data. Now in the
Yeah,
background,
more
the
that
browser
this how
starts
JS
a
manages it when
process
exit
that eventually
promises and
shows
wait
the
in your
user
code.
pop-up. Now, of
Got
course,
it.
we don't know when the user is going to interact with this pop-up, but that's not a problem because this is not happening on the call stack, so our entire website is still responsive in case other tasks need to run instead. Now, finally, the user clicks on allow. So the API receives the data from the browser and uses the success callback to handle this result. However, it can't just push that callback back onto the call stack. This could disrupt an already running task and just create very unpredictable behavior. So instead, the callback gets pushed to the task queue, which is also called the callback queue for this exact reason. The task queue holds web API callbacks and event handlers to be able to get executed at some point later in the future. And this is where we finally get to the event loop. It's the event loop's responsibility to check if the call stack is empty. And if that's the case, so if nothing is running, it then gets the first available task from the task queue and moves. Instead, the callback gets pushed to the task queue, which is
So there's a call stack. We have the web APIs. Then we have the task queue. Micro task, okay. And then the event loop.
also called the callback queue for this exact reason. The task queue holds web API callbacks and event handlers to be able to get executed at some point later in the future. And this is where we finally get to the event loop. It's the event loop's responsibility to check if the call stack is empty. And if that's the case, so if nothing is running, it then gets the first available task from the task queue and moves this to the call stack where it's executed. So now finally, we handle the results and the user's location is logged to the console. Another very popular callback-based web API is setTimeout. And setTimeout also receives a callback and a delay. So let's see how that works. So first we encounter a setTimeout. And this again gets added to the call stack, but all it does again is register that callback and also the delay with the timer's API. And in the background, the browser will actually handle that timer. Then we have another setTimeout, and again, it registers the callback and the delay. Now our timers are still running, and we have a console log end of script. This just gets added to the call stack and logs end of script, nothing asynchronous here. Now after 100 milliseconds, the browser's like, hey, 100 milliseconds expired. So now the callback moves onto the task queue. There's nothing on the call stack right now, so this moves onto the call stack where
The web API is just to register initialized calls that are made. It's not as important as the other three. Okay, so basically the call stack and the task queue and micro task queue is the main powerhouse basically inside of the browser, right? Like she mentioned in the first place, even though it's like
again,
tiny part of it.
Callback is pushed onto the task queue, call stack is empty. So
it's just all those things in action, yeah. So the event loop, it's more like a thing that it do. It's not like a specific place like the call stack or task queue, right? Like it's just the thing that, yeah, okay.
So it's just very important to remember that when you have a setTimeout and a delay, it's not the delay until it gets moved onto the call stack. No, it's the delay until it gets moved to the task queue. So this means that the delay that we specify might not actually be the delay to execution. Because if the call stack was still very full with other tasks and this could run for many more seconds, the callback would still have to wait in the task queue until the call stack is empty. So just something to keep in mind. So long story short, the callbacks provided by web APIs are pushed onto the task queue when the asynchronous task completes. So what about the promise-based ones? If you haven't checked out my promises video yet, I highly recommend you watch it.
Yeah, it's just the name of the process.
Basic promise knowledge while explaining this entire flow. Whenever we work with promises, we're working with the microtask queue. The microtask queue is a special queue dedicated to then catch finally callbacks, a function body execution after await, the queue microtask callback, and the new mutation observer callback. So only those callbacks or those function body parts get pushed onto the microtask queue. So it's very specific. However, the event loop prioritizes the microtask queue. So whenever the call stack is empty, the event loop first ensures that the microtask queue is entirely empty. So it gets all the tasks from the microtask queue, moves them onto the call stack where they get executed, and only then will it move to the task queue. And after each task in the task queue, it again checks the microtask queue. And a popular promise-based web API is fetch. So let's see what happens behind the scenes when we invoke fetch. So whenever we call fetch, it's added to the call stack. This is just responsible for creating a promise object, which by default is pending. The result is undefined, and we don't have any promise reactions just yet. It also initiates that background network request that's handled by the browser. Then we move on to the next line. We have the then handler, and this creates a promise reaction record where we have res console log res. The server still hasn't responded, by the way, but we get to line 4. So there we have a synchronous console log end of script. So now end of script is logged to the console. And then finally, the server returns some data. So now the promise state is set to fulfilled. The promise result is now the response object with the data that we got from the server. And the promise reaction handler is now also pushed to the microtask queue, right? Because it's a then callback, and that gets pushed to the microtask queue. The call stack is empty, so the event loop checks the microtask queue, moves this to the call stack, where it eventually logs the result that we got from the server. Something to keep in mind with microtasks is that a microtask can also schedule another microtask. And this means that the event loop is just constantly handling the microtask, and it can never actually get to the task queue. It would just have to wait indefinitely. So we're kind of creating an infinite loop, an infinite microtask loop, freezing our entire program. I believe in Node, you can set like max tick depth or something like that, which prevents this exact thing from happening. But just make sure that you don't accidentally end up doing that. And we can also promisify a callback-based API. So for example, we can rep the get current position with a new promise constructor. And for the success callback and the error callback, we just pass resolve and reject. So this can be a pretty nice solution just to improve the readability within your code base a bit. All right, a little quiz to see if you kind of understand it. So we have a promise resolve with a then handler, we have a setTimeout, we have a queue microtask, in which we have another queue microtask, and then we have a console log 5. It's up to you to see what gets logged. So pause the video now and let's see if you got it right. And the right answer is 51342. So let's see why. First, we have the promise resolve, and this just creates a new promise object that's instantly resolved. Then on the next line, we have the then handler. The promise is already resolved, so in the background, it does create that promise reaction, but the handler is immediately pushed to the microtask queue. Then we have set timeout, which is responsible for initiating that timer. So the callback and the delay get passed to the API, and in the background, the browser starts some sort of timer. Then we have queue microtask. So the call is added to the call stack, and this queues that callback to the microtask queue. Then we have the synchronous console log 5, so this gets pushed to the call stack and logs 5. And in the meantime, the 10 milliseconds are up, so the callback from set timeout is pushed to the task queue, because this was a callback-based API, so task queue. Our script is done, the call stack is empty, so the event loop checks the microtask queue. And there we have the promise handler callback, and this eventually calls console log 1, so 1 is logged to the console. Then we have the queue microtask callback, and within this callback, we call console log 3, so 3 is logged to the console. Then we call another queue microtask, and this queues another microtask with its callback to the microtask queue. However, the event loop has to ensure that the microtask queue is entirely empty before moving on to the task queue. So that callback is immediately moved onto the call stack again and logs 4. Now finally, the call stack is empty and the microtask queue is empty, so the first available task from the task queue is moved onto the call stack, and this eventually logs 2. So now we have 5, 1, 3, 4, 2. So let's just recap what we've covered so far. So JavaScript is single-threaded. It can only handle one task at a time. We can use web APIs to interact with the features leveraged by the browser, and some of these APIs allow us to initiate async tasks in the background. So the function call that initiates an async task like that is still added to the call stack, but this is just to hand it off to the browser. The actual async task is handled in the background, so it does not block the call stack. The task queue is used by callback-based web APIs to enqueue the callback once the asynchronous task has completed. Then we have the microtask queue, which is only used by promise handlers, the async function bodies after awaits, the queue microtask queue callbacks, and the new mutation observer callbacks. This queue has priority over the task queue, and the event loop ensures that this queue is entirely empty before moving on to the task queue. And after handling each task from the task queue, the event loop again checks the microtask queue to ensure that nothing has been added in the meantime. You often come across asynchronous JavaScript, and if you aren't entirely sure why things execute a certain way, it might just be very discouraging. But I hope that my explanation for the task queue and the microtask queue and the event loop kind of helped you understand why certain parts of our code execute at a certain time. Of course, as always, if you have any specific questions, feel free to reach out, but I also highly recommend that you kind of just play around with it yourself. Like, try using set timeout, try using queue microtask, just to get a better sense of like, oh yeah, okay, I understand why this runs at this time and why this doesn't execute, stuff like that. Good luck, and
Cool. Oh, what is this? V8
I'm pretty
engine.
Hallie, and today I'm going to give you a pretty high-level walkthrough of basically everything that happens, going from our human-friendly JavaScript file all the way down to something that computers can understand. And there are so many parts to this process, but for now I'm only going to focus.
Okay. This is actually fun. But oh shit, where was the last video? Wait.
Welcome back, everyone. We have now completed the core sections in this course. Math, search, and sorting algorithms are fundamentals that you should know as a developer. For the last section, let's go over a few miscellaneous problems. The Cartesian product of two sets, the climbing staircase problem, and the Tower of Hanoi problem. The Cartesian product solution has a time complexity which we haven't seen so far. The climbing staircase problem is a good interview problem, and the Tower of Hanoi is a great example of how recursion can simplify the solution to a problem. Of course, there are hundreds of other great problems out there, but unfortunately, we don't have time for all of them. The hope is that by the end of this course, you will have the problem-solving mindset and on your own, Google and understand the solutions to various problems. Now, the approach for this section as well remains the same. I'll start off by mentioning the problem statement. What is the ask from us? I will then request you to pause the video and try solve the problem. We will then implement the solution together. I highly recommend you code along with me rather than just watching the video. Finally, we will determine the big O time complexity of our solution. Alright, let's get started with...
You'll never actively need to use this knowledge, like the last mentions, for each reason, how the order of things happens, yeah. Trouble understanding execution order, yeah, okay. Got it, got it.
In this video, let's take a look at the Cartesian product of two sets. Here is the problem statement. Given two finite non-empty sets, find their Cartesian product. Now what is Cartesian product? Well, in mathematics, specifically set theory, the Cartesian product of two sets A and B, denoted by A cross B, is a set of all ordered pairs A comma B, where A
You
is
could be
from
asked
set
about
A
universe, so
and
it's
B
just
is
useful.
from set
Yeah.
B. We would be representing
Some of the
this set as
questions
an array in
in the
JavaScript.
interview that I
Example,
had, which I
if set A
failed,
contains 1 and
which
2
leads
as
me to
elements,
learning this
set
again.
B contains 3 and 4 as elements, their Cartesian product is an array that contains smaller arrays with elements 1, 3, 1, 4, 2, 3, and 2, 4. Similarly, if we have two sets with elements 1, 2, and 3, 4, 5, the Cartesian product is an array that contains smaller arrays with elements 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, and 2, 5. Now, what is our idea behind the solution? Well, if you ask me, this is a pretty simple problem. You have to traverse each array and pair each element in the first array with each element in the second array. I'm guessing you feel confident about solving this problem.
No, I'm not.
So go ahead and give it a try.
Okay, I'm gonna try it, but it's gonna be very, very poorly, so...
Now, what is our idea behind the solution? Well, if you ask me, this...
The thing is, I think because I didn't really... It was my fault, to be honest. It was more like a... How would I say it? Like the thing is, it was sort of like a mismatch of timing, like bad timing, in the sense that I got that interview once I got back in Germany, but the role is specifically for Indonesia. But you know what? I end up, you know what? It's okay. Let's just give it a try. And because I didn't really prepare for anything, because I was preparing to go back to Germany and I didn't study, I didn't prepare because I thought, man, I'm not sure if I could take it because I'm going back to Germany, but the role is for in Indonesia. But then, like, when the interviewer asked a question which was supposed to be simple, it's a recursion, I went blank. I guess because I haven't practiced, because a lot of it was focusing on moving and I wasn't really settled yet here. I still need to, like, oh, I haven't get my what do you call it? Like, I haven't get my proper card, I haven't get my thing settled, I haven't even had like a blanket to sleep. It was a bit, so it was like, yeah. Yeah, first of all, I am dumb to not really prepared, which is that's why I'm doing this, which I should have prepared because it was supposed to be easy. It was recursion. That's why when this video has about recursion, it's like, oh my god, it wasn't supposed to be hard. But the thing is, I couldn't really. I was just froze. I think I went into panic. I went blank. I couldn't really think. I couldn't really say a word or anything. I'm just like staring at the screen and the interviewer. So it was like, oh fuck. It's my fault, half of it, because it was like the role I get was for like an Indonesian company, but at that time I already decided to go back to Germany, and then I was like, oh, it's a miscommunication, mismatch, and I was like, "Ah, you know what, it's fine, let's just go do it and see how it goes." But yeah, basically, I just went blank. That's the first. The second one, I only made it to the behavioral interview with the HR, so no technical yet, but I didn't get past the technical round. I only got to do the behavioral, like basic stuff, but from the HR. That was the second, and I got a third one, and the third one was my fault because they require German, and my German was okay, so, and yeah, I guess it was because my German wasn't good enough. I think they require professional, fluent level, almost up to like C1, while I'm only like around B1. And during the interview, I explained and answered some in English, and they were okay with it. But I guess they were really expecting for full on German. So yeah, so uh, one, I failed because I'm unprepared and miscom, and I was like, I'm already in Germany, and I was for an Indian company. The second one, I only go through the behavioral interview, didn't get to the technical. The third one is because of language barrier. So yeah, it's basically three of the my don't not really, those three are like the weak spot. Like first of all, I wasn't prepared, and that's why I'm trying to be prepared now with this. The second one was I don't know why I didn't get past the behavioral. That one I asked for a feedback, but they haven't replied, so I'm just gonna let go. And the third one is definitely because of language barrier, and they need someone that is able to be fluent in English, because even though the thing is, I was very upset about the third one, the language one, because the tech stack they're using is React, Next.js, and everything. And I was like, oh, I'm already quite familiar with it and been making project with it, so that was a bummer. But yeah, that was the basically the experience, and yeah, I guess I'm trying to conquer and remove those like weakness with this and doing it again. But yeah, I think after the Cartesian product, I'm gonna stop because I want to update the website for Namrapan Studio. I want to change the background and I want to add a new project that they did. So yeah, basically it's just an update to the site. So let's do Cartesian product, and after that we will
In
finish.
this video, let's write the code to find the Cartesian product of.
Because I think, I don't know, I really like making things that work and looks okay. Not the good, not the best one, of course. I need to really relearn CSS again. That's why the goal for next week is continue basic from CSS and HTML again. And yeah, once I feel comfortable with HTML, CSS, and JavaScript, I want to make a blog based on like the suggestion. Once you figure out that the base case is essentially the point where you stop the logic and begin to exit out. I see. Okay, I'll check out the front end master. Is it on YouTube as well, or only on the front end master's side?
Sets. In Replit, in index.js, let's begin by defining the function signature. Function Cartesian product, parentheses, and curly braces. The function will have two parameters, array1 and array2, which represent the two sets whose Cartesian product we need to find. For example, if array1 is equal to 1, 2 and array2 is equal to 3, 4, 5, then the Cartesian product will be 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, and 2, 5. Now what we need first is an array to store the ordered pairs. So within the function body, const result is equal to an empty array and return the result at the end. We now need to populate the result array. In order to form the different ordered pairs, we need to traverse.
Here, this is what I'll say regarding solution operation based on what I've seen you do overall stream. Please do, man. Like, I know a lot of the thing is hard, but I think I need to start really focusing on which one or which roles that I really, really want. And like pinpoint that from there, right? I guess on one side, I'm still confused on myself and still wanted to learn a lot of things. But yeah, for your base job, yeah, yeah, true. And that's why, yeah, that is so true. That is so true, and that's why I'm relearning this again because it all comes down to that basic understanding and that logic, and yeah, that's what I wanted trying to do here. You're right. You're absolutely right.
For that, we can make use of a loop. Let's use a for loop to traverse array 1 and another for loop to traverse array 2. So for let I is equal to 0, I less than array 1 dot length, I plus plus. For let j is equal to 0, j less than array 2 dot length, j plus plus.
Yeah,
Result
understandable.
push.
Yeah.
An array where the first element is array 1 of I and the second element is array 2 of j. What we are doing here is for each element in the first array, pairing with each element in the second array. The pair is then pushed into the result array. And that pretty much is our code to find the Cartesian product of two sets. Let's run the code and verify if it works as expected. You can see we have 1, 3, 1, 4, 1, 5, 2, 3.
Yeah. And so much is 300 with your object array understanding and method. Yeah. Okay. So yeah, okay. Thank you. I think I bookmark some site here to go over like JavaScript basics. So that's definitely gonna be uh the aim for the next upcoming weeks. Okay.
2, 4 and 2, 5, which is the expected output. Now what is the time complexity of our function? Well, we have two for loops. From our experience so far, you might think that the time complexity is O of n square, or quadratic. But a very important difference from what we have seen earlier is that the two arrays are not of the same length. Array 1 is of length n and array 2 is of length m. They could be of the same length, but they can also be different. So the time complexity in this case is O of m times n. It is dependent on the length of both array 1 and array 2. If the lengths are equal, then it would be O of n square.
Okay.
Small yet noticeable point to keep in mind.
The basic idea is you can take any data, like from a response, and put it into a structure that you can best use to solve the problem. Okay.
Thank you for watching. Make sure to subscribe to the channel, and I'll see you in the next one.
Sorry, forget to put this. How come is it's undefined? Oh my god, sorry. That is such an... Sorry, I just keep failing to stupid stuff. Like, I don't know why. Okay. Okay, at least that's... Okay. Nice, okay, cool. Okay, let's go back to this. I want to check the Google Drive first. I forgot the... I'm just gonna use that. Sorry. Okay, so I need to go check the... Google Drive? And then... Um... Is there any, like, tips on how I could think more algorithmically, algo rhythmically and like structurally, because sometimes, okay, I face a problem on my head. Oh, you can do this, but then it turns out it's not as complicated as the way I thought it would be, and the implementation on the code is actually much simpler. And I feel like it keeps doing like the hardest thing, and the implementation is just not easy compared to like, oh, you can just use this, you can just use, oh, use this function or use this method to easily do this. Like the previous example, like using the slice or using something, like I don't remember, or I didn't think of doing that, and I guess I'm just not used to it. And how can I get used to it? I mean, I guess the easy thing is just to continuously doing it, but sometimes like, okay, how do I start? Like, okay, I have this problem with the method on my mind is already wrong, so how do I actually start? And I guess this is what is like stuck, at least with me. Uh, oh, the task, yeah, I want to update this website with new project, because they just made a new project, and kind of want to update them to add that new project. So yeah. Yeah, I'm so sorry. I don't know why the chat has like so much delay. Maybe I should open just the YouTube chat so that it wouldn't be delayed. But the thing is, it consumes so much RAM, and I don't have that much RAM. Uh, so I'm just gonna pop this chat out and just use that, you know. There we go. Okay. Is it better? Okay, so yeah. Extract here. And I need to convert all these JPEGs to okay, wait. I think I asked create this path file. To like convert PNG to a P, but if I want to use it, could I just... Okay, wait, I need to change the name. No, I need to change the format file first. Nice. The thing is, if I open Discord, it's gonna consume so much memory. And I don't have that much memory on my computer, so I think I'm gonna open the if using Discord, I just need to open it on my phone because if I open it using my computer, it's just the fan is gonna go crazy. Okay, so this is the file that I already downloaded. So the next thing I need to do is to convert them. But I forgot how to use the file. Okay. If I use convert to a P. Your consistency, well, that consistency came out of desperation. So gotta do what you gotta do, man. This is the way the world works right now is a bit scary. So we gotta work even better than other people, you know. How could I gotta stay consistent, man. Sorry, it's about to grok. So okay. Oh, do I need to use relative path? Sorry, absolute path then? Okay, let's give it a try. Let's create a new file called convert to p.fat. And inside here, we would have all of these. 1 second, guys. So it's gonna take the input folder. It's gonna count the PNG or WebP. Okay, so okay, this is much better because it's gonna loop the PNG or WebP, and it's just gonna convert them. Let's make it 9. Let's make it 90. Oh, this is nice. Okay, so let's give this a try. Protein will be now ready for. So we can do so we can do ls, and then we can do set convert. I don't know if that works, but that should work. How do we run the file with params? Okay. Hey, there we go. That's nice. Okay, that works actually. Cool. Okay. And if we go here, that should be WebP right now. Nice. Okay. Okay. So I'm gonna delete all the JPEG and just keep it. I know there has to be an automation way to do this, right? Either using PowerShell or using the .bat again. Okay, cool. Since we only have this much anyway, so it's fine. So I think we can make this into the thumbnail. Is there like to rename them easily? Like a way to without the space? I don't really want them to have the space. Okay. You know, let's just do it manually. It's fine. I know there's supposed to be an easier way to do it, but it's fine. It's fine. It's fine. Because there's only 3 anyways. We do not have the logo, so we need to really find it by ourselves, huh? Okay, it's okay, no problem. Just need to find a good. Okay. Okay, that should work, but why is it not working? Okay. I'm just not trying to solve anything. So currently I really need to manually insert, rename and everything. It's so manual and it's so terrible because all the data, project data is like in this single file. But yeah, this is like the current state of the site because at the time it was so messy. Like this website has been delayed for over like 2 3 months, and I was like, you know what? As long as it works, it works. This like method is just so janky, so hacky, and causes way too much problem. Like, um, Mr. Harold, have you ever experienced where like your site can be accessible in USA or in Canada, but then in other countries that they are not accessible? But when, okay, so the problem with this site is that I deploy it in Cloudflare Pages, the domain, everything is in Cloudflare. But when my friend or the client trying to access it from Indonesia, it just keeps on loading and stuck on the loading screen. But when my friend tested and he changed to a different DNS using Google's or Cloudflare's, it worked. The website was able to load. I don't know why, but yeah, that happens, and I'm so confused because the so I would say the website has paid off in the sense that there is some client that they got from the site and they are able to access it. But when my friend tried to access it using his phone, it wasn't able to access it. But then when he changed the DNS, he's able to access the site. I read some of like the Cloudflare like forums or like help pages, things like that, and a lot of people in Indonesia seems to write that a lot of the ISP have like trouble with Cloudflare because Cloudflare CDN hosts like explicit contents or things like that, but I don't know why. Maybe because of that. Like the ISP blocking the site, but I don't know. I don't know. I'm just very confused. Okay, sorry. Get back to this. Bro, I wish I am, bro. I hope I am. Hopefully in the next few months. I'm trying to. At least that's the goal. Oh, it's a WebP already. Okay, nice. That's cool. Okay. That is cool. It's already WebP, finally. A good place. Yeah, I mean, that's not your fault. That's your service provider. Okay. How it's being served to your customers. If there is some regional restriction, there's an issue on how your site gets served. Yeah. The thing is, yeah, some of them are able to access it, but some other doesn't. And when he uses like data, it worked. But when he uses internet, it doesn't work. But when he changed the DNS to Google or Cloudflare, then it works. So I don't know. Would hosting it in a different place change that? Or like I don't know. Okay, this looks nice. But when you click here, it would open a new page. Yeah, yeah. Okay, cool. No, Google or Cloud is a service provider, but your CDN would be the more accessible and local CDN. Ah, okay. Google Cloud is the servers where the code sits. Okay, got it, got it. Okay. Yeah, your data can be put on a different CDN. If there's no. Because automatically your browser is taking your code and delivering it to your user. That is more accessible to Indonesian customer if that exists. So Google or Cloud is a service provider, but your CDN would be the more accessible CDN to Indonesia. Okay. So yeah, they made like an ad basically for like a internal application, and we just want to add that to the site. You know, cool. And some short movies, some stuff here. But yeah, looks pretty nice, right? Yeah, yeah, yeah. Okay, so now if it matters of where the data comes from, because maybe there's some local restriction on Google Cloud. Okay, so it's yeah the Indonesian government, you know, overcomplicating local Google. Okay, okay, I guess that is good. I just need to upload the video there. So on YouTube, I meant. But yeah, that's the whole thing. So I guess we can commit the file because that's all we need to change as of right now, at least. Oh, that is a good documentary. That was I watched it with my family. It was one of the I think yeah, I think it was like, well, how I forgot what year is it? I think it's either yeah, this one, right? Ice cold. This is such a whew, this is like, oh, this is like a big thing, especially after the thing after the documentary went live. Oh man, it was crazy. Oh, it's remembering to do this. It's like remembering to this meme. It's from Chainsaw Man, right? Yeah, this is basically this is what you're doing right now. Oh my god. Okay. Oh man, the I haven't seen the Chainsaw Man. Then like this one. But it was yeah, it was nice. Okay, let's merge the code, or it's only just changing one file basically. I don't need a test or anything. Okay, this is localhost. This is the actual site. Let's push the changes. I think that should be all because I haven't really added. Let's just add like a to do. But yeah, I guess that's it. It's supposed to be all. You can just and I think it's gonna build automatically gonna build because we just pushed 8 seconds ago. Nice. Yeah, like so I used to work like remotely for like video editing like before when I was like early semester in college, and some of the other team was also from Philippines, and it's just like the thing is, yeah, a lot of Indonesian word and Tagalog are like similar, but then uh it's just sound weird. I think, yeah. It just sounds very, how would I say, yeah, it's like a, how would I describe Tagalog? Yeah, it's gibberish, but then gibberish to, like, at least for me it sounds gibberish, but then there's some like Indonesian word in the middle, like, oh, what? Like, yeah, I guess it's the same for you too, right? If it's like, yeah, the Tagalog and the Indonesian one, but uh, my God, very fun. Ooh, like remotely, or when you were in Philippines, or where was it? Let's just merge it. Yes, it's fine. No need, no need for Copilot to check. It's built. This is changing one file. It's fine. We can confirm. Yay, cool. Okay. I have 3 branch. Oh. Okay, we can delete those as well. And it should be the latest one. We'll see. Oh, I know that word. I think it's like Lima. Yeah, Lima is 5. What other is it? Okay, listen, it's fine. Yeah, remotely. Oh, from like North America to like Southeast Asia. Oh my God, isn't it like 12 hours, 16 hours, something like that? Is it? Yeah, 12 to 16 hours. Holy, that is crazy. Okay, let's check the production, see if it's already visible. Okay, nice. Cool. And the next thing that I want to do is add this to Google Search Console. So we can change it to the side. Google Search Console. Something like that. Ugh, that is insane. If it's like 14-hour different. Cool. So regarding the 68 site, I saw this on Twitter, Mr. Todd Ham's website, and I really like it. And I think I really like it. This is such a nice thing, and I am clearly inspired for like the next version of 68 site. I want this to be like a camera so that so that the user, like the viewer, could like scroll between the projects that we have. So at least I have the idea, I just need to know and probably learn a little bit about Blender. Oh God, this is such a nice thing. Yeah, definitely get heavily inspired by this. This is such a cool website. I love it. Canvas API. Oof, like see that the animation, the okay, but yeah, definitely gonna learn. You know what? I'm just gonna ask. How? Okay. Oh, see that? So that's what I want. I like this. So let's just say that if you click to the camera would be able to like rotate or like go to next, and it will go to like the different projects that we have. Such a good idea. This is it's gonna be such a huge inspiration. That's such a cool animation. WebGL. And I guess he's using React 3 is 3JS as well. So I guess we could what's the error? Because currently right now, like I don't know how to interact with like this. Maybe later we could interact with it much more properly. Like what I want is like users could go to the camera and then like click a button to go to next, and then they will like go through like a carousel of the projects, because as of right now I can only do this, right? Yeah, but definitely gonna be okay. This doesn't work. Okay, some projects are indexed. This is the path icon. It's not working. Like all that knowledge puts you in a different category of front-end dev. Okay. Okay, some are indexed correctly, like this one. Oh, this got indexed? That is such a cool. Okay, this is so cool. This is the image that I have from the short movie. If you guys want to watch it, please do watch it. Because, yeah, of course, for someone who's been doing this for 20 years, it's gotta be as good as this, right? I'm gonna connect to Mr. Hamilton, and once I'm able to finish the site inspired by him, I'm gonna message him and like, oh, your website inspired me to create this. Please roast it. But this is such a cool website. I love it. Mr. Hamilton. Okay, nice. At least one of our images got indexed. So we're gonna what do you think is like, okay. Like if I add like blogs or any other like um content stuff here to increase like traffic and like would that better for the SEO? What? Why haven't I followed that, bro? Oh shit, I haven't. Oh my god, I'm so sorry. Man, I really need to open this stuff more often, man. Okay, I think that should be all for today. Wait, I need to fetch that. Oh, that's why. The things that helps you are pretty standard regardless of the solution you choose. Semantic HTML, accessibility, content, etc. So I think adding content would be like the next step to improve the SEO, right? Because I've already tried to really optimize all the accessibility, all the best practices and everything. It's just like the bad thing, like, okay, of course Lighthouse isn't everything, but like the only bad thing about the Lighthouse is I couldn't get to use like the proper 3D model size that is small enough. So yeah, I don't know if you can see, but I'm able to get the accessibility best practice and SEO to 100. It's just that the performance, it's terrible because I couldn't really get the model, the 3D model, to use like a compressed version. And maybe because I haven't really played around or know more in depth regarding like the 3D Blender stuff, but I'm definitely gonna looking forward to that. So yeah, we'll see how that goes. I think yeah, adding content, right? I think adding more content would be very nice. But okay, I'm gonna write it down in my yeah, okay, I already added add blog into Namapan Studio. I already added here, so that's nice. This just goes to Namapan Studios and it's fine. We can add nice. Okay, cool. Yeah, for performance always think about how fast you can deliver your full render content. Yeah, it's definitely because of this 3D model. I'm definitely gonna need to find or at least like learn how to optimize the 3D model. Because at the time I tried everything, or at least to my knowledge, and it didn't work, but it's okay. We'll try again.
Boleh bagi nggak cerita paling apes lo yang bisa kita jadiin sinematik?
Cerita paling apes, oh ada nih cerita. Jadi pagi itu tuh gue udah telat banget. Gue baru bangun jam 7:30 dan gue ada kelas jam 8. 15 menit lagi mulai kelas dan posisi gue masih di kereta tuh. Turun dari kereta gue harusnya naik bis kan, naik dikun. Tapi kalau telat dikit mampus gue. Mau gak mau gue naik BIM. Gue kira bakalan lebih cepet tuh. Tapi kayak gak nyampe-nyampe, lama banget. Ya udahlah, gue abis itu udah nyampe gedung, gue langsung lari ke kelas. Gue buka pintu kelasnya, tapi taunya dikunci. Barulah gue ngeh, gue telat lihat notif grup. Ternyata kelasnya online.
Sorry. Okay, I guess that's it. Mr. Harold and anyone, thank you so much for watching. I appreciate the support, the comment, and everything. Although it's a bit of a mixed bag today on works. Okay. There's a lot of things to do. But yeah, appreciate everyone. I guess I'm just gonna go back to bed. I'm gonna sleep now. Maybe I shouldn't have to set up for cameras. I shouldn't be strapped for time. It was for a skit, like the content wanted to make like a, how do you say it, like what can you make a simple story or a simple experience into like a short movie. So yeah, a short compilation of the story. Yeah, basically that's what they did, and it's pretty fun. And yeah, probably because she probably late because she set up all the cameras and like, oh, she have to get out from the train, get back in, and like all the other stuff. But yeah, Table is already responsive. Pagination has been done. Better message from it's fine. This one I haven't done, but so I made this, not really made it, but more like vibe coded it because oh shit, what's wrong? What the fuck? Oh, never mind. So I made like a income tracker, not really made, just ask AI to do it, and yeah, it's basically like a template, but that's for another time. Okay, I'll see you tomorrow, or if not tomorrow, then some other day this week. But yeah, hope everyone have a great day, afternoon or night.